Good day everyone, I am Shalwa Pasay and I'll be the one to present first to our topic, which is sensors. So first is to define what is the sensor, second is the classification of sensor, and third is the types of sensor and their uses. What is sensor? So sensor is an input device which provides an output, which is the signal, with respect to a specific physical quantity or the input. Classification of sensors. So sensors are classified into active and passive types, with active sensors requiring external power and passive sensors generating output without it. They can also be categorized by their meanings of detection, such as electric, biological, or chemical methods, and by the conversion phenomenon, such as photoelectric or thermoelectric. Additionally, sensors are classified as analog, producing continuous output, or digital, generating discrete data for conversion and transmission. Active sensors are those which require an external excitation signal or a power signal. So there are some examples of active sensors: the ultrasonic system, the distance sensor, the pressure sensors, the humidity sensors, the chemical sensors, and other things. The next is the passive sensors. So on the other hand, do not require any external power signal and directly generates output response. So examples of passive sensors are the camera, radiometer, spectrometer, light sensor, temperature sensor, sound sensor, magnetic sensor, and other things.
Different types of sensors. So there are 25 different types of sensors. First is the temperature sensor. Temperature sensor is one of the most common and most popular sensor. As the name suggests, it senses the temperature, so it measures the changes in the temperature. So there are different types of temperature sensors like LM35, DS1, 8B20, thermistors, thermocouples, RTD or resistive temperature devices, and many more. So, temperature sensors can be analog or digital. In an analog temperature sensor, the changes in the temperature correspond to the change in its physical property like resistance or voltage. So LM35 is an example of a classic analog temperature sensor. So coming to the digital temperature sensor, the output is a discrete digital value, usually some numerical data after converting analog value to digital value. So DS18B20 is an example of a simple digital temperature sensor. Temperature sensors are used everywhere like computers, mobile phones, automobiles, air conditioning systems, industries, and etc. So next is the proximity sensors. A proximity sensor is a non-contact type sensor that detects the presence of an object. It can be implemented using different techniques like optical, like infrared or laser, sound, magnetic sensor, capacitive, and etc. So some of the application of proximity sensors are mobile phones, cars, industries, ground proximity in aircrafts, and etc. And next, we have accelerometer sensor. An accelerometer is a handy sensor that measures acceleration. It detects both the direction and the magnitude of acceleration, whether it's from movement or the force of gravity. So these come in different types, such as capacitive or piezoelectric, each suited for specific applications. For example, capacitive accelerometers are commonly found in smartphones to detect orientation. So, accelerometers can output data in both analog and digital formats. A typical analog accelerometer will change its voltage output in response to movement. Digital models like those in modern electronics directly provide numerical data that applications can use. You'll find accelerometers in various devices, from mobile phones and tablets to cars, where they help with stability control and accident detection. And the fourth one is infrared sensor or IR sensor. IR sensors are light-based sensors that are used in various applications like proximity and object detection. These are used as proximity sensors in almost all mobile phones. There are two types of infrared or IR sensor, the transmissive type and reflective type. In transmissive type IR sensor, the IR transmitter, usually in IR LED, and the IR detector, usually a photodiode, are positioned facing each other so that when an object passes between them, the sensor detects the object. The other type of IR sensor is a reflective type IR sensor. In this, the transmitter and the detector are positioned adjacent to each other facing the object. When an object comes in front of the sensor, the infrared light from the IR transmitter is reflected from the object and is detected by the IR receiver, and thus the sensor detects the object. So different applications where IR sensor is implemented are mobile phones, robots, industrial assembly, automobiles, and etc.
Next sensor is a pressure sensor. Is a tool that measures the force exerted by a fluid or gas. It can detect subtle changes in pressure and convert them into an electrical signal. So there are several types of pressure sensors, including piezoelectric, strain gauge, and capacitive sensors. Each type has its specialty. For instance, as piezoelectric sensors are excellent for dynamic pressure measurement like sound waves, and pressure sensors can also be analog or digital. In analog sensor, the output is a continuous electrical signals that varies with the pressure. So in digital sensor pod, on the other hand, convert this information into digital data that can be easily read by computers. So tagasagaran magamit ni siya is in automotive to monitor tire pressure or fluid system. Then pwede po siya sa industrial for monitoring pressure in pipelines, tanks, or machinery. Then next is light sensors. Sometimes also known as photosensors, light sensors are one of the important sensors. A simple light sensor available today is the light dependent resistor or LDR. The property of LDR is that its resistance is inversely proportional to intensity of the ambient light. When the intensity of light increases, its resistance decreases and vice versa. By using LDR is a circuit, we can calibrate the changes in its resistance to measure the intensity of light. There are two other light sensor or photo, which are often used in complex electronic system design. They are photodiode and phototransistors. All these are analog sensors. So ang light sensor pod is mayo siya sa kanang smartphones and camera to automatically adjust the screen brightness based on ambient light. Then, pwede po siya sa solar panels to monitor sunlight and optimize energy collections. The next is ultrasonic sensor. Is a non-contact type device that can be used to measure distance as well as velocity of an object. An ultrasonic sensor works based on the properties on the sound waves with frequency greater than that of the human audible range. Using the time of flight of the sound wave, an ultrasonic sensor can measure the distance of the object, similar to sonar. The Doppler shift property of the sound wave is used to measure the velocity of an object. So, ang ultrasensor pod is for robotics, for obstacle detection and distance measurement in autonomous robots. The next is flow and level sensors. Flow and level sensors are all about keeping an eye on liquids and gases, whether it's measuring how fast sometimes flows or checking how much is left in a tank. These are the go-to tools. You might come across different kinds like ultrasonic sensors that measure without touching the liquid or float sensor that sit right in it and rise or fall with the level. Whether they're analog or digital, these sensors are super helpful. Analog version give you a smooth signal that changes with the flow or level, while digital ones break it down into numbers that are easy to read and use. Then, ang flow and level sensor pod is mayusi sa water treatment for monitoring the flow rate of water in pipes and tanks. Then, pwede po siya sa oil and gas industry for monitoring the flow of fluids or gases in pipelines. The next is smoke and gas sensors. One of the very useful sensors in safety-related application are smoke and gas sensors. Almost all of offices and industries are equipped with a several smoke detector which detect any smoke due to fire and sound an alarm. Gas sensors are more common in laboratories, large scale kitchen and industries. They can detect different gases like LPG, propane, butane, methane, and CH4 and etc. Ang kini pong smoke gas sensors is used for home safety and smoke detectors and carbon monoxide alarms in homes. Then, pwede po siya sa fire safety systems for quickly detecting fires and other fire hazard in commercial and residential buildings.
So, microphone or sound sensor. A microphone, often used as a sound sensor, captures sound waves and converts them into electrical signals. This transformation allows device to analyze or amplify the sound. So, example ana kay kanang microphone sa headset or karaoke mic. So, ang tingog nimo makuha niya like kung bistorya ka or makanta niya iyang i-convert into electrical signals para madungog nimo sa speaker. So next is alcohol sensor. So as the name suggests, an alcohol sensor detects alcohol. Usually, alcohol sensors are used in breathalyzer device which determine whether a person is drunk or not. So law enforcement personnel uses breathalyzer to catch drunk and drive culprits. So example no kanang breathalyzer ng gamiton sa police. So ang paggamit ana is ipahuyop sa device niya tan-awon kung naabay alcohol sa imong ginhawa. So mo nilang gamit to determine if a person is drunk or not. So next is PIR sensor. A PIR or passive infrared sensor is your go-to gadget for detecting motion. It works by picking up infrared light from objects in its viewing area. Whenever something warm, like a person or animal, passes by, it notices the change in infrared radiation and triggers a response. So, example here is kanang automatic door sa mall. So, ang PIR sensor ang nagbantay kung naay tao nga duol na. So, unya, abli din na ang pultahan. So, ang sensor kay makadetect siya sa body heat sa tao nga malabay. So, mao nga matrigger niya ang pag-open sa door. So next is touch sensor. Touch sensors essential in device like smartphones, tablets, and laptops detect touch via finger or stylus. Modern touch sensors are predominantly capacitive due to their accuracy and superior signal to noise ratio. So example ani kay kanang atong cellphone. So kung motap ka sa screen, madetect dayon sa touch sensor ang imuhang input mo nga makaselect ka og apps or makaswipe ka sa imong feed. So, next is color sensor. A color sensor is a useful device involving color sensing applications in the field of image processing, color identification, industrial object tracking, etc. So the TCS3200 is a simple color sensor which can detect any color and output a square wave proportional to the wavelength of the detected color. So example here is a barcode scanner sa grocery na gamit og light sensor to read different patterns and colors. So, also printer kay gamit pud og color sensor, so ang sensor nagdetect sa color sa ink ug papel para ma-sure nga accurate ang mga printouts.
To continue, we are now in the humidity sensor. If you see weather monitoring systems, they often provide temperature as well as humidity data. So measuring humidity is an important task in many applications, and humidity sensors help us in achieving this. Often all humidity sensors measure relative humidity, a ratio of water content in air to maximum potential of air to hold water. Since relatively humidity is dependent on temperature of air, almost all humidity sensor can also measure temperature. Humidity sensors are classified into capacitive type, resistive type, and thermal conductive type. DHT11 and DHT22 are two of the frequently used humidity sensor in DIY community. The former is resistive type while the latter is capacitive type. So next is a position sensor. So a position sensor detects the position of an object or point within its environment. It converts the position data into understandable output, typically an electrical signal. So there are various types of position sensors, so including linear position sensors, rotary position sensors, and angle sensors. So each type is tailored for specific application. So for example, linear position sensors are often used in manufacturing equipment to ensure precise movements. Position sensors can be analog or digital. So when we see analog sensors, it provides continuous data that changes linearly with the position. While when we say digital sensors, it is the output process positional data in a format that digital systems can interpret easily. So these sensors play a crucial role in numerous fields, from robotics, where they help the process control, to automotive system, where they ensure optimal engine performance and safety. So now let's proceed to tilt sensor, so often used to detect inclination or orientation. So tilt sensor are one of the simplest and inexpensive sensor out there. Previously, tilt sensors are made up of mercury. So hence, they are sometimes called as mercury switches. But most modern tilt sensor contain a roller ball. So next is strain and weight sensor. A strain and weight sensor measure for a force or load applied to an object. It works by detecting the strain or deformation that occurs when the object is under stress. There are different types of these sensors, like strain gauges and load cells. As strain gauges are often used in mechanical testing, while load cells are commonly found in scales and industrial weight systems. These sensors can be either analog or digital. So an analog sensor produces a signal that varies with the force applied, while the digital sensor converts the signal into readable data. So strain and weight sensors are used in many areas. You will see them in bathroom scales, kitchen scales, and industrial equipment, where their precise weight measures is crucial. They help ensure accuracy in manufacturing, packaging, and everyday household items. So next is gyroscope sensor. A gyroscope sensor measures the orientation and rotation of an object. It helps track how an object is spinning or turning in different directions. So a gyroscope came in various forms, including mechanical, optimal, and MEMS, which means microelectronic mechanical system gyroscope. So a microelectronic mechanical system gyroscope are the most common of today, so found in many customer electronics. So these sensors can be either also analog or digital. Analog gyroscope produce a continuous signal that varies with the rotation,
while digital gyroscope convert this information into data that can be easily read by the devices. A gyroscope sensor are essential in many devices, from smartphones and gaming controllers to drones and car navigation system. They help with tasks like screen orientation, motion sensing, and maintaining stability in flight.
And then optical sensor. An optical sensor detects light and changes in light intensity. It converts this information into an electrical signal that devices can understand. So, optical sensor is usa ka sensor nga makadetect og light. For example is LDR or light dependent resistor. Kini nga sensor nag-usab og sa iyang resistance depende sa kahayag. Mas ubos ang resistance kung hayag ug mas taas kung ngit-ngit. Ginagamit ni sa mga street light aron mosiga automatic kung ngit-ngit na. Then infrared sensor or IR sensor. Nakabantay kini og infrared nga kahayag nga dili makita sa mata. Mahimo kining gamiton para sa pag-ila sa mga lihok o distansya, like sa mga remote control o automatic sliding doors. And then photodiode. Kini usa ka electronic device nga sensitive sa kahayag nga nagamit sa electric current kung matumbok sa kahayag, sama sa mga detector o camera light meters. Then fiber optic sensors. Ginagamit ang optical fibers aron makadetect sa mga kausaban sa kahayag o vibrations, like mga advanced nga medical imaging o communication systems. So, gigamit ang optical sensor sa automation, medical devices, o bisan sa everyday gadgets sama sa mga mobile phone o smart appliances. So, gamit ang optical sensors, may bala nato ang mga lihok sa atong mga digital lights. And then, capacitive sensor. A capacitive sensor detects changes in capacitance to measure the proximity or touch of an object. It works by sensing the electrical properties of the object it comes into contact with. So, kaning capacitive sensor kay usa ka klase nga sensor nga nagamit sa capacitance aron ma-detect ang duol o pagtandog sa usa ka butang. Ang capacitance mao ang pag-imbak og kuryente sa usa ka conductor. Ang sensor magamit sa pag-ila kung naay mga butang nga nagdikit o nagduol sa sensor. Bisan pa man kung dili kini pisikal nga natandog ang sensor, kung ang sensor makadetect sa pag-usab sa kapasidad, maghatag kini og signal nga nagpasabot nga naay pagduol o pagtandog nga nahitabo. Example ani is anang touchscreen sa cellphone. Ang touchscreen nagamit og capacitive technology diin mag-detect siya sa proximity o touch sa imuang tudlo. Pinaagi sa pag-usab sa kapasidad sa screen, kung imong itandog ang screen ang electrical properties sa imong tudlo mag-usab sa capacitance sa screen sa mga lugar nga imong itandog. Ang sensor dayon mag-process niini og magtugod sa device nga makabalo kung asa nga bahin sa screen ang imong gitandog. And then piezoelectric sensor. A piezoelectric sensor measures changes in pressure, acceleration, temperature, strain, or force by converting them into an electrical charge. It works using the piezoelectric effect, where certain materials generate an electric charge when mechanically stressed. So, kining piezoelectric sensor kay usa ka klase nga sensor nga nagamit sa piezoelectric effect aron masukod ang mga kausaban sa pressure, acceleration, temperatura, strain, or pressure. Persa. Kini nga sensor na-convert sa mga kausaban ngadto sa electrical charge. Ang piezoelectric effect nagpasabot nga ang pipila ka materials maka-generate og kuryente. Kung kini ma-stress o ma-press, busa kung ang sensor makasinati o pag-press o pag-igos sa usa ka bagay, mag-produce kini og electrical signal nga nag-represent sa kausaban sa pressure. So, example ani is microphone. Usa ka example na nagamit sa piezoelectric sensor. Kung magstorya ka sa microphone, ang pressure sa hangin gikan sa imo ang tingog magporma og mga vibrations. So, ang piezoelectric sensor sa microphone makadetect sa mga vibrations. Og mag-convert ni sa electrical charge. Ang charge dayon magpadayon sa system aron maproseso ang sound signals ug mahimong audio output. Ang piezoelectric sensor sa microphone mao responsible sa pagkuha og pressure changes sa hangin o pag-convert niini ngadto sa electrical signal nga magamit sa pag-record o pag-transmit sa tingog. Thermal sensor. A thermal sensor measures temperature by detecting thermal radiation or changes in heat. These sensors are essential for monitoring and controlling temperature in various applications. So, thermal sensor sa klase nga sensor nga nagsukod sa temperature pinaagi sa pagdetect sa thermal radiation o mga kausaban sa kainit. Ang mga thermal sensor gamit sa pagmonitor o pagkontrol sa temperature sa daghang mga application sa mga appliances, makina o building systems. Pinaagi sa pagkolekta sa heat o kainit nga gikan sa palibot, ang thermal sensor makahatag og information bahin sa kasamtangan sa temperature. One of the examples sa thermal sensor is infrared thermometer. Usa kini ka klase sa thermal sensor. Kini nagamit og infrared radiation aron magsukod ang temperature sa usa ka object nga walay direct contact. Ang sensor magdawat og infrared rays nga gihatag sa object ug ang sensor magprocess niini aron mahibal-an ang temperature sa usa ka object. RFID sensor or radio frequency identification sensor uses radio waves to read and capture information stored on a tag attached to an object. It helps in tracking and identifying items without needing direct contact or line of sight. For example, is kanang access control sa mga buildings. So, ang mga empleyado magamit og RFID key cards aron makasulod sa building. So, kani nga sensor mooy kanang magbasa sa tag or sa imong keycard para makasulod ka sa building. Kung ang imong keycard valid, ang sensor maghatag og signal aron moabli ang pultahan. So kini usa ka epektibo nga system para secured ang building kay dili ni kinahanglan nga magtakilid o ang tawo mogamit pa or kanang susi para makasulod. So ang RFID sensor nagtugot nga ang pagsulod o pag-access mahimong dali o kanang mas safety.
Lastly, chemical sensor. A chemical sensor detects and measures the presence or concentration of chemical substances in an environment. It converts this chemical information into an electrical signal for analysis. So, chemical sensor helps us see or measures chemicals that are not visible to the naked eye. For example, if you have a sensor in a room and there's a gas leak, mo-detect ang sensor ug mo-send og signal so we can know if something is wrong. Here's the summary of the types of sensors and their uses. First, temperature sensors used for controlling HVAC systems in homes and offices. Next, proximity sensors used for detecting objects on automatic doors. Accelerometer sensors used for screen orientations in smartphones. Next is IR sensor or infrared sensor used for remote controls for TVs and other devices. Next is pressure sensor used for monitoring tire pressure in vehicles. Next is light sensor used for adjusting screen brightness on smartphones. And then ultrasonic sensor used for parking assistance in cars. Next, flow and level sensor used for managing water levels in tanks. Next, smoke, gas, and alcohol sensor used for detecting smoke and gases leaks in homes. And then microphone or sound sensor used for voice recognition in smart speakers. And then touch sensor used for touchscreens on smartphones and tablets. And then color sensor used for color detection in industrial sorting machines. Next is humidity sensor used for controlling humidity levels in greenhouses. Next is magnetic sensor or Hall effect sensor used for detecting the positions of rotating objects. Next is position sensor used for tracking the position of machine parts. Next is tilt sensor used for detecting the tilt of gaming controllers. Next is PIR sensor used for motion detection in security systems. And then strain and weight sensor used for weighing items and digital scales. Next is gyroscope sensor used for stabilizing drones during flight. And then optical sensor used for adjusting lighting in smartphone systems. Next is capacitive sensor, used for touchpads on laptops. And then piezoelectric sensor, used for detecting vibration in musical instrument. And then thermal sensor, used for temperature control in ovens. Next is RFID sensor, used for tracking inventory in warehouses. And then lastly is chemical sensor, used for monitoring air quality. Real-time application of using different sensors. So our example is autopilot system in aircraft. Sensors, these are the eyes and ears of the autopilot. They constantly collect information about the aircraft's surroundings and conditions. The image list example like position, height, speed, temperature, and location. And then computer, which is the brain. It receives the data from the sensors, processes it, and decides what actions are needed to maintain the flight plan or adjust to changing conditions. And then lastly, which is the output or action part. Based on the computer's calculation, the autopilot sends signal to control the plane's movement. The diagram shows example like engine, flaps, motors, and wings. These are controlled to adjust speed, altitude, and direction. That's all for our topic on sensors. Thank you.